Hello everyone, welcome to the post-contest discussion of the Code Forces round 1014. My name is Abhinav and this is Daily Eliminators. Let's get started. Okay, so before moving on, I would like to tell you a little bit about our newly launched version 2 of your favorite CP31 sheet. So in this newly launched version, you would have problems from 800 rating up till 1900 rating. There are 31 hand-picked problems for each rating, which are carefully chosen so that every problem teaches you a unique idea. In the upgraded version of this seat, there's a new interface where you can see that you can sync your progress from your Codeforces account, as well as there's a dedicated discussion session for each problem. There's also a leaderboard in the sheet where you can find your friends and compete with your friends on who solves more problems. Okay, so along with that, each week, like 7 to 8 video solutions of this sheet would be released. So no wasting time searching for the right problems. The link to the sheet would be in the description. Do check it out. Okay, so let's get started with our first problem of the discussion, which is Kamilka and the sheep. Okay, so Kamilka has a fork of n sheep, the ith of which has a beauty level AI, and all AI are distinct. And it's given that Kamilka can choose a non-negative integer d and give each sheep d bunches of graphs, after which the beauty level of each sheep increases by d. Basically, there's an array A and one can choose a D to increase all the values in the array by D. So Kamilka must choose exactly two sheep and take them to the mountains. If the beauty level of these two sheep are X and Y, then Kamilka's pleasure from the walk is equal to GCD of X and Y, where XY is the greatest combination. To find out the maximum possible pleasure that Kamilka can get from the walk. Basically, what is given here is you are given an array. So you are given an array and what you need to do is you can pick any integer d. Okay, so d is any positive integer or zero, okay, non-negative integer. Just pick any integer d and do a plus d to every value of the array. Okay, so all the values in all the values of the array you would do a plus d. After that, the new array that you get after doing a plus d to every element, for that new array you need to compute what is the GCD of any two elements from the array AI and AJ. Okay, so I'm writing it AI dash and AJ dash, which denotes the new array A, which is creating after doing a plus D to every element. Okay, and you just need to find out what is the maximum value you can get for this. Okay, so say for example, let's take the second test case. So in this test case, what you can do is this is the array A given to you. Let's suppose you pick d is equal to 3. What would be your new array? It would be 5 plus 3, 8, 4 plus 3, 7. Then this would be 6, 5, and 4. Okay, this would be the new array after adding plus 3 to all the elements. And in this array, like let's suppose you pick this and this, these two values, I equal to 1 and 5. Okay, so if you pick I equal to 1 and j equal to 5, what would be, so that means your x is 8, y is 4, and your GCD of 8 comma 4, this would be 4. So this way you get a GCD of 4, and for this particular array 4 is the maximum that you can get no matter what d you choose or which two elements you choose, because the answer for this test case is 4 obviously. So how do you generalize this and find out and reach to your maximum answer? Okay, so to understand that, let's look at what we actually need to do. Okay, so you are given an array A1, A2, A3, AN. This is the array given to you. From this array, what you need to do is you need to pick any arbitrary positive integer d, and you need to select two indices I and j. Okay, these are the three things that is upon you to choose. Okay, you can choose anything among them. And what you need to do is you need to maximize this value, ai plus d and aj plus d. Okay, because you would add plus d to every element, and then you put any two elements, so that element would effectively become whatever was the initial ai plus d, and the other element would effectively become initial aj plus d. So you need to find this value. Okay, you need to find out this value. Okay, what is this value equivalent to? Like using the property of GCD, you know the property of GCD, that GCD of any x comma y is same as GCD of x comma y minus x. Okay, I hope you know about this property. So using this property, we can write that this GCD would be GCD of, let's take any one of them. Let's take ai plus d and their difference. So ai plus d minus aj plus d. So dd would get cancelled out. You get ai minus aj. Whatever is the difference. If this is negative, then take aj minus ai. Okay. So whatever is the absolute difference between them, you can write it like this. Now, if you look at this, then one of the terms, this absolute difference is now constant. It doesn't depend on d, because dd got cancelled out, and now this term, it doesn't depend on d. Okay, so among all the ij that you can do, whichever difference is most suitable, you will pick that. Okay, so let's suppose for now you are trying to pick the d. So this does not depend on d. And what is this value actually? This value is, since you can choose a d, that means you can make this value anything greater than equal to ai. So any value greater than equal to ai, you can make this first argument any value greater than equal to ai, because d is on you to pick. Okay, you can pick any d, you can pick even up till infinity. So basically you need to maximize this value, where one term is constant. Okay, I and j you would pick. Let's assume I and j are picked. I'm just talking about d. Okay, let's say I'm iterating through all the I and j. Like n is very small, you can even iterate through all that. For a particular I and j, when I and j are fixed, you just need to pick such a d so that this thing is maximized. What would be the d you would pick so that this thing is maximized? Okay, so if you look at this second argument, this is constant, and this may vary up till infinity. So what is the GCD of any two numbers? What is the maximum that you can get for this? So you know, like for sure, if you are taking the GCD of any two numbers x and y, that should be equal to, greater than or equal to both x and y, like less than equal to, I'm sorry, that should be less than equal to both x and y. The GCD cannot exceed either of the elements. Like this is a very basic property of GCD. So I can say that the maximum I can reach, like this value I can increment up till infinity. This value I would increase. But this is my limiting value. So I can say this thing, whatever, the maximum I can make it go is up till ai minus aj. Okay. It cannot exceed this value. Now, can I, so the maximum achievement that I can do with this picking a suitable D would be make the GCD this. So can I make the GCD this? So whatever this value is, let's say this value is some Y. Now here I can add a plus D, this D can go up till infinity, anything. So if I can create a multiple of Y, if I can create a multiple of Y here, so if this thing is y and here I can create a multiple of y, then I'll say the GCD of any multiple of y with y would be y. Okay, so if I want to make the GCD equal to this value, then I would have to make this a multiple of this. And you know, by picking any arbitrary, you can always do it. Like there are multiples of y up till infinity, so you can just pick some very big value of d so that this overall sum becomes a multiple of y. You can always pick such a value. So you can always make this GCD equal to y, which is the difference of the two numbers. So basically the maximum GCD you can obtain for any two numbers is their absolute difference. Now, what is the overall maximum GCD you can get if you can pick any two numbers is the maximum difference between any two numbers. So in this array, you just need to pick two elements having maximum difference. So pick two elements with maximum difference, and whatever that maximum difference is, that is your answer. So I can say what would be your answer if in an array you want to pick two elements with maximum difference. Pick the maximum element in the array and the minimum in the element in the array. These two elements would only have the maximum difference. So your answer is simply the maximum element minus minimum. I hope this logic is clear to you. So we can move on to our code. Code is quite simple. Just take the input, calculate the maximum using a max function, calculate the minimum using a min function, and your answer is simply maximum minus minimum. Print your answer. What would be the time complexity of this? Calculating maximum would take order of n time, calculating minimum would take order of n time, and just subtraction and print the answer. So overall time complexity is order of n. Overall space complexity would also be, you are using an array of size n, so order of n. Okay, and if you look at the constraints, n was up till 100, so even you could have run a brute force of n square, n cube, that would also be fine here, but okay, we did it in order of n, so it doesn't matter. Okay, so I hope this problem is clear to you. Let's move on to the next problem. Okay, so the next problem is problem B, which is Ladybug. As soon as Dasa Purava crossed the border of France, the villain were kidnapped her, whatever let the story be. The password consists of two bit strings A and B, each of which has length n. In one operation, Ladybug can choose any index from 2 to n and perform one of the following actions. Swap AI with BI minus 1 or swap BI with AI minus 1. Okay, basically swap any two adjacent elements belonging to different strings. One to A, one to B. That's what the two operations are. So Ladybug can perform any number of operations, and you can perform this operation any number of times. The password is considered checked if she can ensure the first string consists only of zeros. Help her understand whether or not she will be able to save the unfortunate index. Okay. So you need to finally make sure that the first string consists of only zeros. So perform these operations any number of times so that the first string contains only zeros. If you can do this, then answer a yes. If you can't, then answer a no. That's what the problem is. Okay, so let's look at this test case. What I can say, this is your array A. This is your string A, this is your string B. Okay, after that, you can perform two types of operations. What you finally need to do is make this array contain all zeros. Here you can see there are some ones. So you need to remove these ones from the array A, from the string A, and make it contain only zeros. Now, in order to reach there, you have two types of operations. First is swap AI with BI minus 1. Second operation is swap BI with AI minus 1. Okay, so these are the two operations that you can perform. Basically, if you are picking any AI, you can swap it with BI minus 1. If you are picking any BI, you can swap it with AI minus 1. So the available swaps are this, this, this. So using the first type of operation, these are the available swaps. Using the second type of operation, the available swaps are this, 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 this. Okay. So by using these available swaps, you need to transform this array into all zeros. So here, one possible way is use this swap. Okay, after this swap, this would become 1, this would become 0. Okay, there is this one, so you need to swap it. So let's use this swap. So after using, okay, initially we use this swap. Now we are using this swap to make this 0 and make this 1. Okay, then we can use this swap to make it 0 and this as 1. Okay, and we can use this swap to make this 1 and this as 0. Now you can see this array A has 0 0 0 0 0 0, all zeros. So our job is done. So there is a way to make this array contain all zeros, so our answer would be yes for this test case. Okay, um, like you can see for the second test case, our answer was yes. Okay, so I hope this is the problem statement is clear to you. Now how do we solve this problem? Okay, let's look at this operation, what we are doing. So let's say you have an array A. Okay, it is A1, A2, A3, A4, A5, and so on. Let's say you have up till A6. And you have an array B, B1, B2, B3, B4, B5, and B6. What are the available operations? Available operations are this, and this. These are the swaps available to you. So if you like look at any particular value, if you randomly pick any value, what values can come at this place? If you try to think, so this can be swapped with this. Okay, so this value can come. This can be swapped with this. Okay, so this value can come, or this value can in turn be swapped with this. So by using two swaps, this and this can come here, or this can be swapped with this. So using one swap here, two swap here, three swap here, this value can also come here. So if you try to look, then this, okay, this particular group of elements, they are all connected. Like, or if you take this particular group of elements and consider it as a new array, then in this new array, you can swap any two adjacent elements. So if let's say you consider a new array, let's say I'm naming it as ARR1. This new array contains this B1, then A2, then B3, then A4, then B5, then A6. Okay. So in this new array, you can see these two are connected. So basically you can swap these two. These two are connected. So you can swap these two. These two are connected. You can swap these two, swap these two, swap these two. And let's say you make another new array containing these elements. Okay. So you can see that this group of elements and this group of elements, they are not connected by any of the swaps. So basically you cannot transfer any element in this position to somewhere in this position or this position, because these all are connected together and these all are connected together. So but these two groups are not connected with each other. So you can basically separate them out into two groups. So this was one group and our another group was this A1, B2, A3, B4, A5, B6. Okay, and all of them are connected. If you see, this is connected, A1 with B2, A1 with B2, B2 with A3 is connected, A3 with B4, B4 with A5, A5 with B6. So I can say that from the given two like strings, you can form this particular and this particular two different arrays like this, and these two are not interconnected. There is no connection between the groups, but among the group, all adjacent elements can be swapped. So basically, you can form any permutation of this group. So you can make one element go anywhere in this group. Same way for this group, you can make any element go anywhere. So you can rearrange these elements in any order. You can rearrange these elements in any order. So what is the final thing that you need to achieve? The final thing that you need to achieve is you need to have all the values in array A to be 0. So what you can do, you can individually compute this for both of these groups. Okay, so you want to make this group. So in this group, whatever is the count of zeros, that should be at least the number of A's in this group. Okay, so for both the groups, so like for this particular group, you would say that the count of zeros in this group should be at least the number of A's. Okay, so number of positions of array A that you have in this group, the count of zeros should be greater than equal to that. Then you would place those zeros in these positions and the answer is yes. Same way for the green one also, the count of zeros in this should be greater than equal to the number of A's. If both of these conditions are satisfied, then you would answer a yes, otherwise you would answer a no. Okay, so I hope now the logic is clear to you what we need to do. Just iterate through. You can divide these groups on the basis of the parity. Okay, so who all would come in the first group? In array A, if I, let's say I'm writing zero based indexing, so all those in array A you have 0, 2, 4. Okay, so all the even indices in array A, and in array B you have odd indices. Okay, so all the like even indices in array A and the odd indices in array B would come in the second array. In the first array, all the odd indices in array A and even indices in array B would come in this particular part. Okay, so I hope now the code can be written in many ways. So how I have written the code is, whenever I am in array A, if in array A I am getting a 0, that means there is no issue, that would remain is 0. But when I get a 1 in my array A, that means I need to, this one need to get replaced. Same way in array B, if I get a 0 in array B, that means I have a 0 extra which can replace some 1 in array A. So this can replace. Okay, so I have one extra 0 which can be utilized to replace a 1. So what I can do is, whenever I get a 0 in array B, I do a plus plus to my, let's say, some score, and whenever I get a 1 in array A, I do minus minus to my score. For the remaining, like in 0 in array A or 1 in array B, it doesn't matter to us. Okay, so whenever I get a 1 in array A or 0 in array B, I would, for this case, I would do minus minus to my score. For this case, I would do plus plus to my score, and I would have to maintain the score of two arrays, this part and this part. Okay, so I would need to decide whether I need to do plus plus in the first score of first array or plus plus in the score of second array based on the parity. Okay, so that way I'll just maintain, like in my code I'm maintaining two variables, f1 and f2. F1 just stores for this particular array, f1 stores for this particular array, Whenever in A I get a 1, I do F1 plus plus. Whenever in B I got a 0, I do F1 minus minus. Finally, if my F1 is greater than equal to 0, that means all my A's can get a 0. It is satisfied. Same for F2. Okay, so let's look at the code. I've taken the input. After that, F1 and F2 equal to 0. So if it is an odd index and value at array A is 1. So for odd indices, let's say these. For these, the array A is belongs to the red part. Okay. So this red part in my code, this I have taken as F2, this I have taken as F1. Okay. So this red part is F2. So if I am at an odd index and array A is 1, then array A belongs to red part F2. So I do F2 minus minus. And same way for odd index, array B belongs to F1, green part. Okay, so for odd index in array B, if I get a 0, then I do F1 plus plus. Okay, and same way for opposite for the even index. In array A, if I get a 1, F1 minus minus. Array B, I get a 0, then F2 plus plus. Okay, once this is done, I just need to check if both my F1 and F2 are greater than 0, I print a yes, otherwise a no. Okay, I hope the code is clear to you. If you look at the time complexity, taking this input, after that, this is running n times and there is just if else conditions. So this is order of n and these are just if else conditions. So overall time complexity is order of n, and overall space complexity is I'm using two strings of size n. So this is the order of n space that I'm using. Okay, so I hope this problem is clear to you. We can move on to the next problem now. Okay, so in problem C, for her birthday, Asuna's n admirers gifted her a tower. The height of tower for the ith admirer is AI. Asuna evaluates the beauty of the received gifts as the maximum among the complete array. So the maximum among complete array is defined as the beauty of the gifts, and you have these operations which you can perform any number of times. In the operation, choose two I and j which are unequal, so two different indices, such that their sum is odd. So the values at those indices ai plus aj is odd. So basically, pick two elements having an odd sum such that ai is greater than 0, then decrease ai by 1, increase aj by 1. It is easy to see that the heights of tower remain non-negative. Okay, so whenever ai is strictly greater than 0, then only you would decrease it by 1. So the values remain non-negative. Find as soon as the maximum possible beauty of the gifts after any number of operations. Okay, so basically you need to maximize the this value of the array. So the maximum element of the value is what you need to maximize after performing these operations any number of times. Okay, so for example, if you look at, let's say, this second test case. So you have n equal to 2 and this array of size 2. What you can do, you can pick these two elements. 3 plus 2 is equal to 5 is an odd number. So you can perform an operation between these two. Let's say this is your I, this is your j. So 2 would get reduced to 1, 3 would get increased to 4. So your array becomes 4 comma 1. Again, you can pick these two values. 4 plus 1 equal to 5 is an odd integer. So minus 1 plus 1, you get 5 comma 0. After this, if you compute the beauty of the array, which is the maximum among the array A, then the maximum in this array is 5. Okay, so 5 is the maximum in the array. This is the maximum you can get. Answer for this is 5. Okay, so I hope the problem statement is clear to you. Let's see what we need to do. Okay, so if you look at the array, let's say any random array. Let's analyze the operation first. What you can do is, in your array A, whatever elements you have, Just pick any two I and j such that ai plus aj is odd. This is your condition. When is the sum of two values odd? If you analyze the parity, either this is odd and this is even, so even plus odd would be odd, or one is even, one is odd, then even plus odd would be odd, or if both are odd, then you would get even, and if both are even, then also you would get even. So these two conditions are not favorable. Favorable conditions are these two. Basically, to have two integers have an odd sum, both of them should have different parities. One of them should be odd, one of them should be even. That's the condition. So basically, you need to pick two values from the array which have different parity, and decrement one, increment another. That's what you need to do. So your operation is, in short, pick two elements with different parity and just to ai minus minus aj plus plus. Basically transfer one value from I to j. Okay, that's what your operation is. Okay, once you know this, now one thing you can, like, for sure say from here only, if in your initial array all the elements, let's say all the elements have same parity, either all are odd or all are even, then can you perform any operation? No, you cannot pick two elements with different parity, so you cannot perform any operation. That means you can't perform any operation. So in that case, what is your answer? Your answer is simply whatever is the maximum element in the array. Okay, whatever is the initial beauty, the beauty would remain same because you can make no changes to your array if all the elements have same parity. So your initial beauty is maximum element in the array. That would be your answer. Okay, now what about the case where, so this case is solved when all the elements have same parity. Okay, so now we need to only solve for the case where some elements have odd and some elements have even parity. So there is at least one element with odd parity, at least one element with even parity. Then we can perform some operations. So how do we analyze this case? For that, what I can say is, let's say, like, let's take an example. Let's say you have an array 2, 4, 5, 8. How much can you reduce this array? Like, or reduce, increase, or get maximize one of the elements? How much can you maximize one of the elements to? So you can understand it like this. Let's say this is 2, this is 4, this is 5, this is 8. So in any operation, what you can do, you can pick two elements with different parity. That's the first thing. So 2, 4, 8 all are even. You cannot pick them in among them. So you need to pick a 5 along with some even element. Let's say you pick 5 and 2. Then what you can do? So whenever you pick 5 and 2, they have different parity. You can pick them. You can decrement one and increment one of the values. So either you could have decremented this, incremented this. Both are okay. So let's say you decremented this and incremented this. After that, one more thing. Once you perform an operation between any two elements, okay. If you perform an operation between any two elements, since you performed an operation, that means their sum was odd. After performing an operation, what operation are you performing? You are doing ai minus minus and aj plus plus. After this operation, can you pick these two elements again? Because this sum would remain the same. This would become -1, this would be +1. So this ai plus aj is not going to get reduced or increased. it would still remain odd. So you can say you can again perform the operations repeatedly on any two values. So you can repeatedly decrement one value and increment another until one of the values reaches 0. So if AI reaches 0, then you cannot pick this AI if it is 0, because AI should be greater than 0. That condition is also there. You cannot make it negative. So what you can do is your operation basically transfers an even value to an odd value. Basically, you had 2 and 5 initially, so you transferred this 2, made this 0, transferred it to 5. That's what your operation is doing. So with every operation, you can transfer an even value to an odd value. Okay, this would become 7. Or if you were decrementing this and incrementing it, this, you can transfer this 5 to 2, but the effect remains the same. If you transfer 5 to 2, this 2 above 5, this would become 7 and this would become 0. Finally, you are getting a 0 and a 7. Okay, a 0 and a 7. So both ways, it's the same thing. So in this case, what you can do, since you have a single odd value only, so one by one, you can transfer this 2 here. It became 7. It is still odd. You can transfer this 4 here. This would reduce to 0. You got a 4 here. This became 11. You can transfer this 8 here. Okay, this 8 would become 0. Another 8. In total, you got 11 plus 8, 19. Okay. So in this case where you have a single odd number, you can see that you can transfer all the remaining even numbers one by one to this and make your final answer as sum of all the elements of A. Now, how can you prove that this is the maximum you can get for this case? Is, can you get more than sum? Like whenever you are performing an operation, the overall sum of the array is not changing. One value is decreasing, one is increasing. Overall sum of the array is constant. So since all the array elements are positive, so having one element greater than sum, then even if rest elements are 0, your overall sum would be greater than sum, which is in invalid case. So the maximum you can get is the sum of the array. So in this case where you had only one odd number, when you had only one odd number, you can transfer all the even numbers to that and make your answer the sum of the array. But what if you have two odd numbers? Can you still do it? Let's say you have 3, 2, 5, 4. Okay. So you would have a 3 here, a 2 here, a 5 here, a 4 here. Now, what is the maximum can you get? Can you make all the elements can get into one element and make it the sum of the array? So if you try, the only operation available to you is pick an even number with an odd number and decrement one of them, increment one of them. So first of all, you cannot do an operation between two odd numbers or between two even numbers. So let's say finally in this you want to stack all of them. So you can stack these even numbers on top, make it 7 plus 4, 11. But what about this 3? You can you stack this 3 over it? Now, whenever you perform an operation between these two, one of them would still remain odd. So this 3 cannot go to an odd number. So like you can say here, you cannot make all the elements go to one of the elements. What exact proof can I give for it? So the exact proof that I can give for it is whenever you perform an operation, let's say, let's say initially, um with C1 or like C0 represents the number of odd values in the array. Okay, let's say C0 is the number of odd values in the array. Like for this array, 3 is odd, 5 is odd. So there are two odd values. So if there are C0 number of odd values, what happens to this value after performing an operation? So you pick two elements AI and AJ which have an odd sum, and then you perform an operation of AI minus minus AJ plus plus. What happened after that? Let's say this was even, this was odd. After AI minus minus, even became odd, odd became even. So even after performing the operations, the number of odd values and the number of even values in the array is not changing. So if initially there were some C0 number of odd values and let's say some C1 number of even values, then no matter how many times you perform the operation, in your final array you would have C0 number of odd values and C1 number of even values. That remains constant. So for this particular array, let's say you want to have your final answer as the sum of the array. So since there are two odd values, so what is the sum? The sum of the array would be even, because the even values would add up to become even, and for every odd value it would become odd, then another odd value would make it even. So if there are two odd values means the sum would be even. If the final sum is even and you want to create this structure where you have all the sum in one element and rest of the elements are zero, for that this element should be even, because this element should be the sum, and the sum is even and all the rest elements are even. That means all the elements are even here, but initially you had two odd values. And you are saying that in your final state you have no odd values. This is not possible. So here I can prove that if you start with two odd values, you can never make that getting your answer as the total sum is not possible. Your answer would be less than sum. Okay, so I'll check, can I get sum minus 1? Okay, that can be the next maximum that I can get. Okay, so to make the answer sum minus 1, it could be this is sum minus 1 and you have a 1, rest of the values are 0. Is this possible? Yeah, this sum minus 1 is odd, this one is odd, rest of the values are even. So you have two odd values, which is same as in the initial state where you had two odd values. So making this state is possible. Like theoretically with this way I can say this is possible. Now can I make it? If I can make it, then my answer is sum minus 1. So let's see, can I make it? So in this case, what you can do, all the even values can get transferred here. Okay, that you can understand from the operation. What about this odd value? How can you make this odd value to get reduced to 1? So this odd value would go with an even value. Let's say you made this. So what you can do is just pick any even value. For all the odd values, first transfer these odd values to the even value. Okay, so if you perform an operation between these two, this would get incremented by 1, this decremented by 1. Again, you can repeatedly perform. So perform it until it get reduced to 1. Because after that, if you perform one more operation and make it 5, then this would become odd. So you don't need to do that. If you make it this odd, then this won't get transferred to this value. So keep it even. So keep the odd value to get reduced until 1 and keep this even value even. After that, this value is already even. Now transfer both of these even values this side. Okay, so this would become 0 and you add a 4. this would become 0 and you add a 4. So overall you would get a 13. So you can see, like, in this structure you have created 1, 0, 13 and 0. So here you got sum minus 1, here got a 1, and rest of the values were 0. So creating this thing was possible. So I can say when number of odd values is equal to 2, my answer is sum minus 1. Okay. So for these two cases, like, we have solved the problem. Like you can see, when the in the first case, when the number of odd values was just 1, we were able to get our answer as sum. When the number of odd values is 2, you are getting your answer as sum minus 1. Let's generalize this thing further. Let's say when number of odd values is 3, what would happen? There would be 3 odd values. Your final sum is going to be, since there are 3 odd values, your final sum is going to be odd. So can you create overall, can you get a total sum in one value? So let's say you have the total sum here and rest of the values are 0, 0, 0. So this sum is odd, but rest all the values are even. You started with 3 odd values and you get only 1 odd value. This is not possible. Okay. Can you get sum minus 1? Let's try. So if you have sum minus 1 here and one of the values are 1, so this, since the sum is odd, sum minus 1 is even, this 1 is odd, rest all values are even. So again you have just one odd value, but initially you had 3 odd values. So this state is also not possible. Now can you get sum minus 2 as your answer? So in order to get sum minus 2, what you would have, your maximum value is sum minus 2, which is even, and you have 2, 1, 1, rest of the values are 0. So like sum was odd, so this is odd, not even. Sum was odd, so sum minus 2 would be odd, and we have two ones which are odd, odd. Okay, rest of the values are even. So here we have 3 odd values, same as our initial. So basically we can see that if you have 3 odd values, you need to maintain 3 odd values in your final state as well. So to maintain 3 odd values, one of the value would be your answer, but rest of the odd values would be reduced to 1 and even values would be reduced to 0. So you can generalize it that if you have x number of odd values in your array, then your final answer is sum minus x minus 1. So there would be x minus 1 once, one of your answer which is sum, which is the bigger value, which would be odd. So you have x odd values and rest even values. So for x number of odd values, your answer is sum minus x minus 1. Even when x is even, let's say for x is equal to like 2, for two values your answer was sum minus 1. Even you can just check for, let's say, number of odd values equal to 4. Even for that, if you have 4 odd values, you are saying that your answer is sum minus 3. Sum minus 3 would be, for 4 odd values, sum is even, sum minus 3 would be odd. Okay, so this sum minus 3 would be odd, and then 3 ones. Okay, 3 of the ones would be odd. So 4 odd values you got, rest 0, 0, 0, 0, even values. Okay, so I hope you can understand how we come up to this formula along with its proof. So my final answer is sum minus x minus 1, where x is number of odd values in initial array. Okay, so this is the case. So this is your answer for when there are at least one odd and one even values. For the basic case where we cannot perform an operation, which I had already shown, that when we cannot perform an operation, your answer is just max of the element. When all the elements have the same parity, you cannot perform an operation, then your answer is the maximum of the array. Otherwise, when you can perform at least one operation, then your answer is this sum minus x minus 1, where x is number of odd values. Okay, so this you can easily compute the number of odd values in order of n time. So in order of n time, you can solve this problem. Let's move on to the code. So for the problem C, you can see, so we iterate over this, we take the input, okay, and while taking the input only, I just compute the number of odd values and even values. So C0 stores the number of odd values, C1 stores the number of, C0 stores the number of even values, C1 stores the number of odd values. So if AI is odd, I do C1 plus plus, otherwise C0 plus plus. So if either the number of odd values is 0 or the number of even values is 0, that means all the elements are either odd or all the elements are even. So we have all the elements of same parity. Then my answer is just the maximum element in the array. This is my answer. And we return out. Otherwise, my answer was sum minus x minus 1. Sum minus x minus 1, where x was number of odd values, which is C1 here in my code. So it is sum minus, accumulate would find me the sum minus C1 minus 1. Okay, so this is my answer. I hope this is clear to you. If you look at the time complexity, taking the input is taking your order of n time for taking the input. This max function is taking order of n time. Accumulate function is also taking order of n time. Overall, there are your time complexity, you can say, is order of n, and your space complexity would be, you have an array of size n and nothing else, so it would be order of n. Okay, so with the given constraints of the problem 2e5, order of n was well accepted. So I hope this problem is clear to you. We can move on to the next problem now. Okay, so let's move to problem D. So what are we given in this problem? In anticipation of a duel with his old friend Fernand, Edmund is preparing an energy drink called Miskin Energize, whatever. Consists of a string S of length N made up of characters L, I, and T, which corresponds to the content of three different substances in the drink. We call the drink balanced if it contains an equal number of all substances. Okay, so you have a string S containing of length N, which contains only characters L, I, and T. So you just need to, okay, then you call the string balanced if there are equal number of L, equal number of I, and equal number of T. To boost his aura and ensure victory in the duel, Edmund must make the initial string balanced by applying the following operation. Okay, so you, whatever random string you are given, you need to make it balanced. Basically, you need to make all the number of L present in the string, number of I present in the string, number of T present in the string, all of them equal. And to do that, you can perform two types of operations. Choose an index I such that Si is not equal to Si plus 1. So if Si and I plus 1, two adjacent elements, are unequal, then you can insert a character X, which is either Li or T, such that X is not equal to Si, not equal to Si plus 1. Basically, if there are two adjacent elements which are different, you can insert the third element in between them. So if there are two adjacent elements which are L and T, you can insert I in between. If there is L and I, you can insert T in between. That's what the operation says. Help Edmund made the drink balance in at most 2n operations. So you can perform at most 2n operations and make the string balanced. That's what your target is. And n is up till 100 only, so you can perform even something like order of n square n cube, but we'll see. So let's look at this first test case, how it's being solved, to understand the problem a little. Okay, so you are in this test case, you are given T, then I, then L, then I, then I. So it is index 1, 2, 3, 4, 5. Let's look at the solution of this first test case. Here, the solution is four operations are performed at index 1, 2, 3, and 4. Okay, this I can say is the solution. So, let's say you pick I equal to 1. So, if you pick I equal to 1, then in between I and I plus 1, you perform the operation. That means T and I, these are different characters, so you can insert L in between. So, your new string becomes in between T and I, you inserted an L. This I got continued. After that, you have L, I. Okay. So, these remained as they were, and in between, you inserted a L. Now, the new indexing is 1, 2, 3, 4, 5, 6. Okay. Then you perform I equal to 2. So in between I and I plus 1, 2 and 3, this is L and I, they are different, so you can perform an operation. So since you have L and I, you would insert T in between. So this would become TL, and if you insert T in between, it becomes LTI and then LII. Okay. New indexing is 1, 2, 3, 4, 5, 6, 7. Okay. Then the next operation is I equal to 3. So after index 3 and 4, since these are different T and I, you can insert a, here you can insert a L. So the string becomes TL T. In between T and I, you insert an L, then it is I, then LII as they were. Okay. Then you perform I is equal to 4. So 1, 2, 3, 4, 5, 6, 7, 8. In between 4 and 5, you insert a character. So it is L and I, so you can insert T in between. So your string becomes TLT LTI LII. Okay. So this is the final string after the four operations. In this final string, you can check whether it is balanced. Number of T's is 1, 2, 3, 1, 2, 3 only. Number of L's is 1, 2, 3. Number of I's is 1, 2, 3. Okay. So all of them, T is also 3, L is also 3, I is also 3. All of them are 3. So the string is balanced. Okay. So I hope you understood what you need to do. So you need to answer this. What is the sequence of operations that you would perform to make it balanced? And you can perform at most 2n operations only. So how do you solve this problem? Okay, so let's come to the approach directly. Basically, the intuition behind this approach was, if I try to explain a little, then whatever string like you have containing LTI, like let's say you have some LLL, okay, then some, like any general string would be like this. Like if you have some consecutive L and L, first thing is, if you have some consecutive characters of same type, in between them you cannot insert anything because these are same characters, so you cannot perform an operation in between them and insert something. So if you have 4L in a group, then these 4L would always remain in the group. You cannot insert anything in between them. So if you have 4L and then let's say there is one T and some one I only, you need to have more T's and more I's in order to balance it. How would you get more T's and more I's? So if you have a lot of consecutive L's, so you cannot perform operations here. When can you perform an operation? When there is some different character. So let's say you start with, your string starts here and then you find this LLLL, then you find some different character. Whenever you find some different character, you know you can perform an operation here. But you have already encountered like 4L's here. So you need to balance it and make 4T's and 4I's as well. You don't know, further ahead you would get maybe eventually 4T's and 4I's, but there's no surety. So what you can do is, here only, like you can perform an operation. What would happen? Let's say you perform an operation here. Between L and T, you would get an I. It would become like LIT. Okay, so you got an extra I if I was missing. Let's say T was missing. How would you get an extra T? After you have performed this operation between L and T, you got an I. That means you have L and I consecutive. So you can insert in between a T. So you would get L T I T. So you can see after these two consecutive operations in between here and here, you got one extra T and one extra I. So this can balance an L. So if there were more amount of L's, you would get some extra T and some extra I to balance that. Then if let's say some T is unbalanced, then get some extra T and L to balance them. So you can one by one balance each of them. So with this intuition, and like you can perform 2n operations in total. So for every character, you can get two extra characters. So for every L, in order to balance this L, you perform two operations here, get an I, and then one more operation, get a T. If there were four L's, let's say you perform another operation here, what do we get? You get a I here. It becomes LIT, IT, whatever. Perform one more operation here. You get a T, L, T, I, T, I, T. So you can see you get TI, TI, TI in between. You initially started with LT. You got this TI with two operations. Perform two more operations. If you perform two more operations, you get a I, you get a T. You would get L, TI, you would get LTI, TI, TI, T. So one, two, three. Three groups of TI, TI, TI you were able to insert after this L. So if initially you have four L's, you can insert four groups of TI, 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 TI in order to balance these four L's. Okay. So these four L's got balanced and then you move to T's. So how many number of, if you get one T, next whenever you get something unequal, you insert a Li in between. Okay. So in between this Ti, you can insert a L. Then between this L, T and L, you can insert an I. So you inserted I and L in order to balance this T. So whenever you got a group of L, you balance with you. If you got 4L, you applied the operation 8 times. You would get 4 I's and 4 T's. That got balanced. Okay. Next, you get a few T's in between. Let's say you have two T's in the initial string. Then if you get two T's, then here you would perform 4 operations to get 2 L's and 2 I's. Okay. That way you can move forward for the last group of elements, for the last I that you have. Then you cannot perform an operation here and get some extra T and L. So in order to balance this last group, you can look at this from the right side. You can perform an operation here again. So once these four L's are balanced, these four L's, okay. So for this test case, what I'm doing, 4L, 2T and I. This was a string given to me. So in order to balance these four L's, here I performed operation 8 times here. So after performing operation 8 times here, you get 4L that were there. Then 4 pairs of I, then T. So TI, TI, 4 pairs. So TI, 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 TI. Okay. 4 pairs. So these 8 characters got inserted with these 8 operations. And then you have this TTI. So TTI. Okay. So after 8 operations, these 4L got done. Like 4L got cancelled out with balanced with 4 TIs. Now you have these 2 T's, then you traverse to next group of elements, 2 T's. So you need to balance these 2 T's. So here you can insert a L and then I. Again L and I. So here you would perform, for 2 T's you would perform an operation 4 times. So after performing an operation 4 times, so whatever was here, same thing, these all were balanced. After that 2 T's, and after 4 operations you get L, I, L, I. Okay. So 2 groups of Li, Li you got, and this I remained. So these 2 T's got balanced with these 2 I and L's. Okay, so this all is also balanced. So until here we have everything balanced. We are left with one extra I. What to do with this I? For the last group of elements, do it from this side. So perform an operation in between here, in between this L and I, to get a T. And then you can perform an operation in between these two, in between this T and I, to get an L. So you got a TL for an I, and it got balanced. So you can say till here it was balanced, then you had TT, IL, IL, and in between you inserted a T first and then an L. So TL and I. Okay. So this group also got balanced, this got balanced, this got balanced. Everything is balanced. So this way, for every character, in order to balance that character, in order to balance a T, you would insert a L and a I. In order to balance a L, you would insert I and a T. So for every character, you are inserting two extra characters. So in 2n number of operations, you can do this. So you would perform exactly 2n operations in this particular algorithm. Okay. So I hope you understood the approach, what construction we are doing. Let's look at the code. Okay. So coding this would be, basically you have to take care of the indices as you are inserting extra elements. Your string is increasing in size and the indexes are also shifting to the right, so you need to keep that in mind while performing the operation. So initially when you are moving from left to right, for the last group, let's ignore that for now. Until the last group, for the first, second, third, fourth, these groups, in order to balance them, where do you perform the operation? So for the first group of 4Ls, okay, if you have a one based indexing here, okay, you need to answer in one based indexing, although in my code I assume a zero based indexing, and in my answer I add up this one extra to convert it into one based. You can do like that. Okay, let's say you have a one based indexing. Then for this L, if you need to perform an operation between this L and this T, the I that you would answer would be 4. Okay, so after that this I is inserted. Then if you need to perform an operation between these two, again 4 would be the index where you would perform the operation. T got inserted. Then in between these two, 4 would remain the index. So if you have a group of 4 Ls, you would perform the operation 8 times on this index 4 only. So in your answer, you would push back this 4 8 times. Okay. But after that, your array would increase by a size of 8. So next, in your initial indexing, this T was at index 5. After performing 8 operations, this T came at index 5 plus 8 equal to 13. 13 would be the new index of this T. So you need to perform an operation at I plus number of operations already performed. That would be the new current index. Original index plus number of operations already performed before it. So that index you need to add x times, where x is the number of times that is occurring currently consecutively. So with that logic in mind, let's look at the code. So I took the input NNS, and then I'm just taking all the, I'm running a loop until n minus 1. Okay, so what I in J, I'm storing the last index where till where my string is balanced, like which is done. The last index which is where we have operated on to balance our string. So initially that is taken as -1 because we are starting with zero based indexing. So we are starting at 0, so I'm assuming -1 is already operated on. So if I see that Si plus 1 is equal to I, so if I am at a current index where the next index is also the same, then I won't perform an operation there. I can't perform an operation here. I would just continue ahead. So I'll just count through. So if this was -1 and I'm taking a zero based indexing, then when I enter here, I see this is L, this is also L. So I move forward. I go here, this is L, this is also L. I move forward. This is L, this is also L. When I move to this L where there is a T ahead, then here I would perform an operation when I get something different. Now, how many times will I perform the operation is number of consecutive L's that I have. How many consecutive L's I have? The last time where I had operated versus where I'm currently operating, the difference between them is the number of consecutive characters that I have. So number of consecutive characters is I minus j. J is the last time where I operated, I is the currently where I am. So until I am getting equal, I do continue. Whenever I get something unequal, there I will perform an operation. How many times? X times x is I minus j. So in my answer vector where I'm pushing back my indexes where I'm performing the operation. So C is the size of the answer vector. Now size of the answer vector denotes how many times the operation is already performed. Number of times the operation is already performed. So where would I perform the operation? The original index plus number of times operate where the operation is already performed. So operation is already performed C times. So I'll insert I plus C into my answer, and since this is 0 based, I add a plus 1 to convert it to 1 based. So in my answer, I would push back I plus C plus 1. How many times? 2x times. Okay. So if I have x consecutive else, I would insert 2 into x times I'll perform an operation. So now I run a loop 2x times and I just push back I plus C plus 1 in my answer vector. So once this is done, I update my j to I, that yes, till j I have operated on, that is balanced. So after this loop, what I would be left with is the last group of characters that I have. Let's say I have some 2, 3 i's here. So this would be the last group of characters that I have left with. So I have to perform an operation here. So here what I need to remember is, let's say this is I and I and I. Okay. If I'm performing an operation here, so the index I would say would be for this. Okay. So the index where I had last operated on J. Okay. There I would perform an operation on J, and after this operation, one character, let's say T, got added. Okay. Then I would perform an operation in between these two. So I perform an operation at J plus 1 basically. So here, before that, I was always performing all the 2x operations at the same index. If I'm performing from the right side, I'm inserting here, then I'm inserting here, then I'm moving ahead and inserting. So I need to move ahead and insert. Or in other terms, what I can say is, first of all, if j is minus 1, okay, what was the minus 1 case? Okay, that we didn't discuss. When would it be not possible to just rebalance this is if you have all the characters same. If all the characters are same, there are no two different characters, you cannot perform any operation, you cannot balance it. Then your answer would be minus 1. If there is any one different character, then you can always balance this by inserting characters in the middle. So when you have all the same characters, then in this loop, if you check this equality case, you would always put continue, and your j would remain minus 1. So if j remains minus 1, that means all the characters are same, and I see out minus 1 and return out. That base case is handled. Now I know all characters are not same and I can perform the operations. So till here my operations are done. For the last group of elements, I need to perform operation. So how many times would I perform the operation? Would be n minus j minus 1. Okay, so like for zero based indexing, if let's say this index is n minus 1, j is the last index where my operation is performed. So how many group of values, what is the size of the last group? It is this minus this minus this would be the size of last group. So it's n minus 1 minus j is the size of the last group. So that's what I've written, n minus j minus 1. So x is the size of the last group. So I need to perform the operation 2x times. Okay. So 2x times I would perform the operation. But here what I would push back in my answer, I have the last group of size x. So where I perform the operation, I perform the operation just before this. So if this is n minus 1, this would be n minus 2, n minus 3, n minus 4. At n minus 4, I would perform an operation. So I'm performing an operation at n minus x minus 1. Okay. So I'm always performing the operation at n minus x minus 1 plus, because this n is not the actual n, this n is the size of the current array. So size of the current array is the initial size plus number of operations performed, answer dot size. So I'll push back to my answer n minus x minus 1 plus answer dot size, or you can say n plus answer dot size, not minus 1. Okay, so plus 1 I would add to convert it to 1 based indexing. This is in 0 based indexing. So minus 1 plus 1 got cancelled. So basically I need to push back n minus x plus answer dot size. Okay, so I'll push back n plus answer dot size minus x. How many times? 2x times. Okay, so this is done. Then I can just see out the size of my answer and all the elements of my answer one by one. My all the operations are printed. Okay, so I hope the logic is clear and the code is clear to you. If you analyze the time complexity, I am running a loop n times, continue, and this loop is running n times, but overall this is order of n because the number of times I put continue, if I'm putting continue x times, then I'm running this loop 2x times. So at max, this thing would run 2n times. Okay, so for every equality I put a continue and I run it 2x times, so like you can say it 3n times. Okay, so it would be order of n only. At max, in this loop I would have 3n operations. Okay, if I have n times continue, then 2n times pushbacks I would have. Okay, this is an if condition. Then this loop again we are running at max 2x times, x can be up till n. So this again is running at max 2n times. Okay, and then I'm printing the answer. So overall time complexity is order of n only, and space complexity is order of, you can see, using a vector of size n, at max like 2n times you would push back to your answer array. So space complexity is 2n, which is order of n. Okay, so with the given constraints of n 100, order of n is well accepted. I hope this problem is completely clear to you. Let's move on to the next problem. Okay, so the final problem of the day is problem E. So what do we have in problem E? So DPP is preparing for a black and white party at his home. He only needs to repaint the floor in his basement, which can be represented as a board of size n cross m. Just a second. Okay, so after the last, so you have to paint a board of size n cross m. So this entire board is painted green except for some K cells, each of which is painted either black or white. So some K cells are already painted black or white, and the remaining cells are green. You need to paint each of the remaining green cells either black or white. At the same time, he wants the number of pair of adjacent cells with different colors on the board to be even after repainting. So basically what you need to make sure with this equation it's written is, for any two adjacent cells on the board, if the adjacent cells are painted with different colors, add a +1. So the count of the pairs of adjacent cells which are painted differently, so that count, if that count is even, then that painting is okay, that's good. So you need to find number of ways to repaint so that the condition is satisfied. So you need to find in how many ways you can repaint so that the condition that number of pairs of adjacent unequal cells is even, that condition is satisfied. So what are the number of ways to paint? So if I explain you the problem once again, or basically what you are given here is you are given an n cross m grid. Okay, so you have an n cross m grid. In this grid, like, okay, okay, let's say you have this n cross m grid. So mm, let's index it 1, 2, 3, 4, 2, 3, 4, 5, 6, 7. Now, in this grid, you are given that initially all the cells are green, like all the cells are green, except for a few cells which are already painted white or black. So there are a list of cells which are already painted. Let's say this cell is already painted white, this cell is already painted white, and there are some cells which are already painted black. Okay, I am representing it with blue because background is already black. I hope you understand. So there are some cells which are already painted black, some cells which are already painted white. Rest all the cells are green. In this, what you need to do is you need to paint these green cells to either white or black, so that in your final representation you need to find number of ways of repainting it. Okay, so number of ways to repaint this grid. So repainting means don't change these white or black cells, just repaint those green cells into either white or black. So number of ways of repainting so that a condition is satisfied. That condition is, in your final repainting, if you consider any two adjacent cells, let's say these two cells are adjacent. If this is white and this is black, then you would add a plus one. Okay. If you consider these adjacent cells, if this is white, this is black, then add a plus one. So the number of times you add a plus one, or the number of pairs of adjacent cells which are different colored, if that count, if that count is even, then you would say that your condition is satisfied. That's your condition. So you need to find number of different ways so that this condition is satisfied. Okay. I hope the problem is clear. Now let's try to think how can you solve this problem. Okay, before thinking, let's look at the constraints where n and m are 10 to the power 9. K is up to 2 into 10 to the power 5. So this grid can be very, very large. N can go up till 10 to the power 9. M can go up till 10 to the power 9. So grid can be 10 to the power 9 cross 10 to the power 9 dimension as well. So just don't think of iterating through every cell and applying some DP and all. That won't work. But what is in the limits is your K, which is 2 into 10 to the power 5. So this K is in the limits. You can do something like order of K. What is this K? The number of number of cells which are already painted. So you need to decide your answer on this, on the already painted cells. Okay. So you need to look at those cells which are already painted, and depending on that you need to decide your answer. So what would be your, how would you decide your answer on that? Okay, so in order to understand that, let's look at the logic what we need to do. So let's look at any grid. Let's see when is your our condition satisfied. Okay. What is the case when our condition is satisfied? So first is, if we have a grid, let's say all the cells are white. Okay. 0 represents white, 1 represents black. Let's say all the cells are white. So all adjacent elements are equal. So number of unequal is 0, which is even. Condition is satisfied here. Okay. Uh, okay. Now in this grid, if I change some 0 to 1, what is the change that it is bringing? So before my count, okay, count was number of adjacent elements that are unequal. This was 0. Let's say I change this one of the grid from white to black. What would happen if I change one of grid from white to black? How would my count change? Now initially that was 0. Whenever there is a change in a grid, only these, okay, so where are we counting? We are counting at every adjacent. So sidewise adjacent, these adjacents, okay, so these are the sidewise adjacents, okay, here we are counting, and vertically adjacent cells, here we are counting. These are vertically adjacent cells. So we need to count among them. So when this value are changing, what all, where all is it affecting? This is affecting this vertically adjacent cells, this vertically adjacent cells, this horizontally adjacent cells, and this horizontally adjacent cells. These are the only 4 cells or the only 4 values that are getting affected, which may be 0 before, now it is 1, 1 before, now it is 0. So whenever you toggle one element in the middle, if before it was like it was a 0 and there were all zeros, and you change it to 1, so before this was contributing 0, now 1 0 1 0 1 0, this is contributing 4. Okay, let's say before it was 0 0 1 0 0, like this. So before it was contributing 1. Once you toggle it to 1, now this became 0, but here, here, and here it is contributing. So now it is contributing 3. So if you look, whenever you toggle any color in the middle, then if it, if it was different with, let's say, any two of the, out of the 4 adjacent cells, let's say 2 of the adjacent cells were different, now those 2 adjacent cells would be same, and rest 4 minus 2 adjacent cells would be different. So if initially x adjacent cells were different, now 4 minus x adjacent cells would be different, because those x would change to same. The 4 minus x that were same are now different. So whatever was your c, if it was 0, okay, and here if you, with this toggle you change from 0 to 4, then your c became from 0 to 4. So with any toggle, what would affect your c? In your c, the contribution of that was x before, now it is 4 minus x. What is the change? You change from x to 4 minus x. The change is, this is getting reduced, this is getting subtracted, this is getting added. So the change is 4 minus x, which is 4 minus 2x is the change. So c is changing to c plus 4 minus 2x. So whatever was the parity of c, if you look at the parity of this new c, so whatever was the parity of this c, the parity of this new c is this modulo 2. So it's c modulo 2, this modulo 2 would be 0, and 2 times x modulo 2 would also be 0. So this it remains c modulo 2 only. Okay, so if you understand it mathematically, it's okay. Otherwise, you can understand like this. Whatever is x, if x was 0, then you are changing from 0 to 4. So changing from 0 to 4, even to even, no change in parity. If you're at x, then 4 minus 1 would be 3. Changing from odd to odd, no change in parity. If x was 2, then 2 would change to 2, no change. If x was 3, 3 would change to 4 minus 1, 4 minus 3, 1, no change. So basically, with this particular operation, there is just no change in your parity of C. So if there is no change in parity of C, the condition won't change if you are toggling any element in the middle. So when would the condition change? So for any element in the middle, you have 4 adjacent elements. So your x changes to 4 minus x, so there is no change. Would all the elements have 4 adjacent elements? No. What about the elements in the edges? Let's say any corner element. For that corner element, it has only 2 adjacent elements. So there are only 2 adjacent elements to it. So for the corner elements, if for this corner element, among these two, there were x elements that were different. After toggling it, there would be 2 minus x. So if x changes to 2 minus x, 0 changes to 2, 1 changes to 1, 2 changes to 0. So even remains even, odd remains odd, even remains even. So for corner elements also there is no change. What about these elements where there are 3 adjacent? Okay. So for these elements where there are 3 adjacent elements, if that is toggled, then among the 3, if there were x elements that was different, now you have 3 minus x elements that is different. So x changes to 3 minus x. So if x changes to 3 minus x, that means 0 changes to 3, 1 changes to 2, 2 changes to 1, 3 changes to 0. Even to odd, odd to even to odd, odd to even. That means parity always changes. So for the elements in these edges which are not corner, for these elements in the edges which have 3 adjacent elements, only for them, toggling them would change your final condition C. The parity of C would only be affected by these elements. So basically you can say for any grid, so here what I want to say is for any grid, if you take any elements in the middle, they would have 4 adjacent elements, no effect to your parity of C, where C is the number of pairs of adjacent elements that are different, whose parity we need to keep even. So for the middle elements which have 4 adjacent elements, this doesn't affect our answer. Same way for the corner elements which have only 4 adjacent elements, two adjacent elements only, they also don't affect our answer because x to 2 minus x parity remains the same. But for these elements in the edges which are in the edge but not in the corner, okay, so these elements, they affect our answer because they have 3 adjacent elements. So x changing to 3 minus x always changes parity. So basically you can see the only thing that affects our answer is these positions. So for any grid you can say exclude these corner elements, exclude these middle elements. These elements in the edges are the only elements that are going to affect your answer. And how would they affect our answer? Initially, let's assume all of them are white. All of them are white. C0 condition is satisfied. Just change, toggle any one of the elements in the edges to 1. That would change your parity of C, and your answer would change to not satisfied condition. Just change any other element, toggle any element, other element in the edge to 1. Again, your parity changes to 0. Your condition is now satisfied. Toggle another element in the edge to 1. Parity again changes to 1. Condition not satisfied. So when is the condition satisfied? You can say condition is satisfied when number of black elements in the edges excluding corners is even. So for 2 black elements, condition was satisfied. When we got 3 black elements, again not satisfied. 4 black elements satisfied, 5 not satisfied. So condition is satisfied when number of like black colored grids at edges where I am excluding corners is even. That I can say is my condition. Evaluating this reduces my condition to this. So I just need to make sure that the number of black colored grids at the edges is even. Done. My condition would be satisfied. Okay. Now, what is my final answer? How do I calculate my answer? So one thing is, for these part in the middle and in the corners, wherever I have a green element, that can be changed to either white or black. It doesn't matter. It is not affecting my condition. So for all the green elements in these areas, they can be either white or black. So the number of green elements in that areas, your answer would be multiplied by 2 to the power of that, because you can then can be anything. We need to focus on these areas. Okay, what if all of these edges are already occupied? So one condition is, if all of these edges are already occupied, that means we just can only paint elements in these places, which is not going to affect our answer. So if my condition is not satisfied, then I cannot make the condition satisfied by painting things here. So either my answer would be 0, or if the condition is satisfied, then my answer would be 2 to the power number of places where I can paint. So that number of different paintings I can do. So first thing is, if all edges are already colored. Okay, here whenever I'm writing edges, I'm specifying excluding corners. Okay, so edges means excluding corners. So if all the edges are already colored, then my answer is either 0. If the condition is not satisfied, we cannot satisfy the condition. So if not satisfied, okay, when would the condition be not satisfied? If the number of black edges, if the number of black cells in the edges is odd. So in this case, we can say, if number of black in edges is odd, then I would answer 0. Else I would answer, okay, so if this is black, then condition is not satisfied, and all of them are already colored. We cannot make change the number of black elements in the edges, so answer would be 0. There is no way possible to make the condition satisfied. Else, if this is even, then the condition is satisfied already. So my answer is, wherever there is a green color, I can replace with it with either black or white. So 2 to the power number of green colors. So here my answer would be 2 to the power number of green colors. What is the number of green colors we have? We have total n into m cells. Out of them, k are already colored. So n into m minus k are the number of green cells, I can say. So this is actually number of green cells is 2 to the power n into m minus k. Okay. So I hope this thing is clear. So this case is solved. If all the edges are already colored, then I would check number of black edges. If it is odd, answer is 0. Otherwise, answer is 2 to the power n minus k. Okay. Now, what about the else condition of this? If all the cells are not already colored. So if all the cells are not already colored, that means we have some green cell in the edges. So if we have at least one green cell in the edges, that means we can make sure that number of black cells in the edges remains even. So if initially the fixed number of black cells is odd, then we can color all the green cells to, let's say, white and one of the green cells to black. Then it would become even. After that, we can just toggle all of them, making sure that the number of black cells remains same. So if we are toggling one cell, toggle one more cell. So basically, if there are 2 to the power x ways, then out of them half of the ways would have condition not satisfied, half of the ways would have condition satisfied. I hope you can understand, because here if you can toggle some of the edge, then in time if you keep it 0, then if at 0 your condition is not satisfied, then at 1 your condition will be satisfied. So whatever are the total number of ways of coloring, out of them half of them would have condition not satisfied, half of them would have condition satisfied, and the total number of ways of coloring is 2 to the power n into m minus k. These are the total number of ways of coloring. These are the number of green cells. Okay, so these are number of ways of coloring. This divided by 2 would be our final answer, because in this case half of them would have satisfied condition, half of them would have not satisfied condition, because you can toggle any cell in the edges to make it satisfied or not satisfied. Okay, so our final answer is, in this case, 2 to the power n into m minus k minus 1. Okay, divided by 2 would add a minus 1 to 1. So in this else case, I can say my final answer is 2 to the power n into m minus k minus 1. Okay, so just that solved. We have solved the problem. Just check if all the edges are already colored. Okay, so among the given k cells, just check if the cell is in the edge and that is white. Okay, just maintain two variables. C0 is for number of white cells in edges, C0 number of black cells in edges. So if the cell, by looking at xy, I can calculate whether that cell is in the edge or in the middle, or whether it is a corner. So if it is in the edge and not a corner, then if it is white, do a +1 to C0. and if it is black, do a +1 to C1. So this way we can compute number of white cells in edges and number of black cells in edges. If the sum of C0 plus C1 that is equal to number of cells already covered is equal to the total number of edges, total number of cells in the edges, that would be my if condition. Then inside again you have a if condition if this C1, the number of black cells, is odd. So if this C1 is odd, print a 0, otherwise print 2 to the power n into m minus k. You have to do it modulo m, so do a binary exponentiation taking model. Okay. And in this else case, print 2 to the power n into m minus k minus. Your job is done. Okay, I hope you understood the logic. Let's move on to the code. So for problem E, first of all, I'll compute the number of white cells in edges, number of black cells in edges. I take the input x, y, c. Now, when do we have cells in the edges? So for all the cells in the edges, either x is 1 or x is n, or y is 1 or y is n. For all the 4 edges, these are the 4 conditions. So if either of them is satisfied, that means we are in the edge. Now, if we are in the edge, we may also be in the corner. So when are we in the corner? So the 4 corners are, this corner is x would be 1, y would be, let's say I'm starting 1 comma 1 from here. So this corner is 1 comma 1, this corner is 1 comma, y is m, this corner is n comma m, this corner is n comma 1. Okay, so either in these, if x is 1, so if x is either 1 or n and y is also either 1 or m, if both of them are together satisfied, that x is 1 or n as well as y is 1 or n, then it is a corner. So if it is a corner, I put a continue. Okay, leave it. Now if this is not satisfied, that means it's not a corner and it's an edge. That is where we need to add. If the color is 0, add to the white cells, otherwise add to the black cells. Okay, so this way we have computed the C0 and C1. Now I just need to check whether this the total number of edges that are already colored, which is C0 plus C1, if that is equal to number of edges. Now how many edges do we have in a grid excluding corners? So here we have n minus 2 edges, here we have m minus 2 edges, here we have again n minus 2 edges, here we have m minus 2 edges. So n minus 2, n minus 2, m minus 2, m minus 2. So 2 times n minus 2 plus 2 times m minus 2. These are the number of edges excluding corners. Okay, so this is 2n plus 2m minus 4 minus 4, 8. So these are the number of edges excluding corners. So I have written if C0 plus C1 is equal to 2n plus 2m minus 8, that means all the edges are colored. Then I would just check if the number of black edges is odd, number of black cells in the edges is odd, that is C1 is odd, then I print 0. Otherwise I print 2 to the power n into m minus k. So I print 2 to the power n into m minus k. Now this power m is a binary exponentiation function. Okay, I have done binary exponentiation to compute it along with taking mod m. Okay, I have declared my m as 1e9 plus 7 that was required in the question. So I print that and I return it. Otherwise I have to print 2 to the power n into m minus k minus 1. Otherwise my answer would be 2 to the power n into m minus k minus 1. Okay, so in this else case, this n into m would never be equal to k, where we could have had 2 to the power minus 1, but that case would, if n into m is equal to k, that means all the cells are covered, so we would fall in this if condition. So writing this extra if is actually not required. I can directly say my answer is this. Okay, so this would also work fine. So my answer is 2 to the power n into m minus k minus 1. I print that in the LCS. Okay, so I hope this code is clear to you. This logic is also clear. What would be the complexity? If we analyze, these are, if I'm taking the input k times, so this is running order of k times. Here, these are simple if conditions. This binary exponentiation would take log of n into m time. Okay, so this would take log of n into m time. This binary exponential would also take log of n into m. So overall, I can say my time complexity is order of k plus log of n into m. Okay, and my space complexity is order of, I am just using single variables, nothing else. So I think space complexity is order of. Okay, this time complexity order of k is given 2e5. Okay, and log of n into m would be 1e18. Log of 1e18 would be approx 60. So this is like 2e5 plus 60, which is well within our limits. So this is completely fine. Okay, so I hope this problem is clear to you and this code is also clear. Thank you so much for tuning in to this PCD. Goodbye.